All right, everybody, we are going to pick up where we left off, and we're going to talk mostly about standard deviation today. We'll talk about a few other calculations, and I'm working with some weird shadows here, so hopefully you can see this video okay without too much trouble. So I'm going to go ahead and give you just kind of a rough definition for standard deviation. We're going to be looking at standard deviation all year long in many different contexts. But for now, it's enough for us to understand that standard deviation measures the typical distance that an observation is from the mean. Okay, so I'll just kind of talk you through an example. Let's say you're looking at a set of maybe test scores, okay? And we know that the mean test score is 82 and has a standard deviation of 5. What that tells us is that a quote-unquote typical student would fall within 5 points of that mean of 82. Okay, or another way of saying it would be that a typical student would fall somewhere between 77 and 87 on this particular test. That's 5 points above and 5 points below that mean of 82 because 5 was our standard deviation. Okay, the formula for standard deviation is on your AP Stats formula chart. You do not have to have it memorized. We're going to practice it by hand, but I will also show you some ways that the calculator can be helpful. So it's the square root of the sum of each individual x minus x bar, which is the mean, squared divided by n minus 1. Okay? And so I want us to go practice this standard deviation formula. There's an example that walks us through it step by step. It's the one on the car mileage per gallons. Let's see. That is letter J. Okay, find letter J in your outline, please. Okay, when I look at letter J, the first thing that I'm asked for is mean and median. I have a very small sample right here, just 5 values. I'm going to put them in order real quickly. 16, 18, 19, 22, and 23. Okay, so x bar being the mean. Okay, I'm going to put all of those into my calculator. 16 plus 18 plus 19 plus 22 plus 23 and divide by 5. I get a mean of 19.6 miles per gallon. Okay, and my median is, my middle value is 19 miles per gallon. Okay, my median right here. Okay, so like we said in our definition of standard deviation, it's based on distance from the mean. So when we're talking about standard deviation, we are always pairing it with the mean, not with the median. The median as the center is useful when we're talking about box plots, when we're talking about quartiles, when we're looking at the 5-number summary. That's when we like to talk about the median as the center. But when we're using standard deviation, we're going to be always pairing it with the mean. Okay, so our process for standard deviation is really spelled out step by step here. So the first thing that we're going to do is we're going to list our observations, our individual x values. I'm going to put them in numerical order. That is not required, but I've already got that list made, so I'm going to go ahead and do it. Okay, so there's my observations. And then the next step is to take each of your individual x's and subtract the mean. We call this the deviations. Okay, when we think of the word deviate, we're thinking of how far are you from where you're supposed to be? How far is each x from the mean? Okay, so I'm going to take 16 and I'm going to subtract the mean of 19.6. 18 minus 19.6. 19 minus 19.6. 22 minus 19.6. And 23 minus 19.6. Okay, so I'll go ahead and calculate each of those. I get negative 3.6. Okay, 18 minus 19.6 should be negative 1.6. This is negative 0.6. 22 minus 19.6 is 2.4. And 23 minus 19.6 is 3.4. Okay, so a lot of times we might think, oh, okay, here's my deviations. Maybe I should add all of those together. And here's the thing about doing that. If I add all of my deviations together, I'm going to get a sum of 0. And that will happen every time, because if you think about what we're doing, we're calculating distance from the mean. So of course it will add up to 0, because we have some values that are above the mean and some that are below the mean, and they all are going to add up to 0. Okay, so that's not super helpful. So what we do instead of taking the sum right away is we first square the deviations. So I'm going to square negative 3.6, negative 1.6, negative 0.6, 2.4, and 3.4. Okay, I'll take a second and do that in my calculator. Negative 3.6 squared is 12.96. Negative 1.6 squared is 2.56. Negative 0.6 squared is going to be 0.36. 2.4 squared is going to be 5.76. And 3.4 squared is 11.56. Okay, so let's look at our formula here. We took each x, we subtracted the mean, and then we squared those values. These are called the squared deviations. This symbol right outside of here is telling us that once I do this, I now need to add all of those together. Okay, so I'm going to go ahead and add those together to find the sum, because my formula is telling me I need to find the sum of the squared deviations. So I'm going to take 12.96 plus 2.56 plus 0.36 plus 5.76 and 11.56. I get 33.2. Okay, that is what we would refer to as the sum of the squared deviations. Okay, and then our last step in findings, well, it's not quite our last step, I guess. Our next last step is to calculate what's called the variance. The variance is everything except for the final step, which is the square root. Okay, so we use the symbol s squared for variance because standard deviation is s, variance is s squared. Okay, the last thing that we need to do to get variance is we need to divide this sum of the squared deviations by n minus 1. N stands for sample size. Okay, our sample size is 5, so we're going to be dividing by n minus 1, which is 4. So I'm going to take 33.2 and divide it by 4, which is 8.3. Okay, one thing I want you to note about variance is it does not get units. And that's because we still are at the squared level. Okay, and so if we think about our original units of miles per gallon squared doesn't really mean anything. It's not a meaningful unit, so we don't put units on variance, okay? All right, last step on our standard deviation formula is to take the square root of our variance, okay? So I'm just going to take the square root of 8.3. And when I do that, I get a standard deviation of 2.881. Standard deviations do get units because they're no longer squared. Okay, so what we might say is that a typical Subaru falls within 2.881 miles per gallon of the mean, which is 19.6. Okay, either above the mean or below the mean, the distance would be 2.881 for a quote-unquote typical Subaru. Okay, now that process probably felt like really long and tedious. We're going to streamline it a little bit, and then we're going to streamline it even more, okay? So if I flip over to the next page here, we're adding a new vehicle to our list. We're adding a Toyota Prius, which is 44 miles per gallon. So now my observations are 16, 18, 19, 22, 23, and 44. Okay? New set of data. When we think about standard deviation, we need to think about it's measuring how spread out things are because it's telling us how far an observation is from the mean. So it's a measure of spread. Just like range is a measure of spread, just like IQR is a measure of spread, standard deviation is another way to measure how spread out our numbers are. Bigger standard deviation, your data is more spread out. Smaller standard deviation, your data is very close together. Okay? If I add a number like 44 to my data set, I need to already be aware that it's going to change my standard deviation. It's going to make my standard deviation much larger. Okay, so it says, how will the standard deviation change? We already know that the standard deviation is going to increase. We need to actually go recalculate it. Remember, the standard deviation is based on the mean. So the first thing that I have to do is I have to recalculate my mean. Okay, so I'm going to do that first. 16 plus 18 plus 19 plus 22 plus 23 plus 44. Now I'm going to divide by 6. I get a new mean of 23.6 repeating. Okay. So to calculate my standard deviation, this is I'm going to streamline the process quite a bit for you. And it's going to be kind of long, so I'm going to scoot all the way over to the side here. Okay. I'm going to take my first x, which is 16, and I'm going to subtract the mean, 23.667, and I'm going to square that. Okay. Deviations squared, and I'm going to add the next one, 18 minus 23.667 squared. And I'm going to add the next one, 19 minus 23.667 squared, and so on. Okay, so I've got deviations squared, sum of the deviations squared. Now I need to divide that whole thing by n minus 1, which in this case would be 5. That value would be my variance. The final step to get to standard deviation is to take the square root. Okay? So how do we type that in where we're not going to mess it up in the calculator? Okay. We are going to type in, at least this is my recommendation, the entire numerator, press enter, divide by 5, press enter, and then take the square root of that answer. Okay. So I will do this with you. 16 minus, and now this 23.667 number is rounded. So I guess technically speaking, we're going to be off by a little bit, but that's not a big deal. In stats, slight rounding issues is not a problem, especially because I'm going to show you something that will eliminate that in just a second. The squareds and the pluses are the easiest thing to forget. Apparently the parentheses as well. Okay, and why is that one so large? Got an extra squared. Okay, there we go. Last one, 44 minus 23.667 squared. Enter. Okay, looks like a really big number, but remember, we're not done. I need to divide by 5. Okay, that's what we call our variance, and then we're going to take the square root of that number to get 10.289. So our standard deviation is 10.289 miles per gallon. Compared to our previous standard deviation of 2.881, we can see that our standard deviation has increased quite significantly because of that outlier, drastically increasing the spread of our data. Okay. Sorry, I'm trying to avoid the shadow for you guys. I hope you're getting all of this. Okay. I'm going to show you a bit of a trick for standard deviation. Okay. Because doing it by hand is tedious, and if you need it for a larger set of data, there's no reason to do it by hand, okay? So I'm going to teach you a skill in the calculator that's going to be really valuable for you for pretty much all of AP Stats, and that's putting data into a list, okay? A lot of what we do in AP Stats in our calculator is in this Stat menu, so that's where we're going to go. We're going to hit Stat. The very first option says Edit. That's where we want to be. Okay, so you've got your lists here. There's several lists available. I think there's 6 defaulted. I'm sure there's ways to add more, although I've never needed to. Okay, so in our list 1, we're going to type all 6 of our values. 16, 18, 19, 22, 23, and 44. The calculator does not care if they're in numerical order or not. I just happen to have them that way, so that's the way I type them in. You can type them in whatever order you want, okay? You've got your numbers in there. Once you hit enter after that last 44, it'll take you to the next blank spot. That's just showing you that all of these are already saved, okay? So hitting enter is kind of like hitting the save button. So now we're going to go back to our stat menu, but this time instead of editing, we're going to ask it to calculate something for us, okay? This whole unit is about one variable statistics, one variable graphs, one variable summaries, one variable descriptions, okay? So we are doing this option 1, one variable stats. And when you hit enter, it's going to ask you, is the list where your data is stored L1? Okay, we pretty much never change that because L1 is the easiest one to use. We're going to hit enter on calculate. You can leave this frequency blank. The only reason we would need that is if we needed to duplicate all of our data for some reason, which we pretty much never need to do. So we'll go down and hit calculate, and it's going to dump us out a list of tons of summary statistics about this data set. The very first one being our mean. Okay, So you don't even have to calculate mean by hand, although typing numbers in to add them and then divide is not hard, okay? But the mean is right there for you, okay? There's a few other things that we could talk about, but primarily we want to look at this fourth one in the list. It says S of X, which is our standard deviation, 10.289, which is exactly what we got when we did it by hand, okay? Calculator does not give you variance. So if you need the variance, we'll talk about those things in just a second. If you need the variance from the standard deviation, you'll just square this value to get back to variance. It's kind of working backwards in the formula, okay? And then you'll notice we've got this little arrow here indicating, hey, look, there's more down below. First thing, this n equals 6. That's just telling us, our sample size. There's 6 data points. And then if we scroll down, you've got 5 numbers right here that should look familiar to you from our last lesson. This is what we call our 5-number summary, and this is used to create a box plot. So far, we've been finding all of these things by hand, which truthfully is not very difficult at all. But if you're in a time crunch, or if you feel like being a lazy mathematician, which I'm all for, put your data in L1, run one variable stats, and you've got your 5-number summary right here. Okay, hopefully that helps a little bit. I want to do just a tiny bit more in your outline, and then that'll be it. Okay. This next example right here asks for 3 things. It asks for the mean, the variance, and the standard deviation. I would recommend that you try this both by hand and with the calculator, just to make sure that you're getting the same answer both ways, okay? I'm not going to walk through that one right now. I can put the answer key up to it later, but I want us to look at letter L. This is typically a problem where I would have you discuss this at your tables, because it's a really great kind of puzzle to have to consider. So we're doing a puzzle is the best way to put this, and we're trying to pick 4 numbers, whole numbers, from 0 to 10, and we've got different scenarios for what that we're trying to satisfy, okay? The first one is choosing 4 numbers that have the smallest possible standard deviation. So when you think about these scenarios, I want you to remember that standard deviation is a measure of spread, okay? It tells us how far typical observations are from the mean. So it's a way to measure how spread out our data is. Okay? So thinking about picking whole numbers from 0 to 10 with repeats allowed, what would be 4 numbers that have the smallest possible standard deviation? I want you to pause the video, talk to someone near you, think about that for a little while, try to come up with 4 numbers with the smallest possible standard deviation. Once you've done that, I want you to also think about picking 4 numbers from 0 to 10, repeats allowed, that have the largest possible standard deviation. Okay? And then answer part 3. Is there more than one choice possible for either A or B? I'll let you think about that for a little bit. Okay, so I'll go ahead and tell you 4 numbers that have the smallest possible standard deviation that I came up with would be 2, 2, 2, and 2. Remember, repeats are allowed, whole numbers between 0 and 10. 4 numbers that have the largest possible standard deviation need to be 4 numbers that are the furthest apart that we could possibly get them. Okay? In my mind, the furthest that I can get apart would be to use bookends. 0, 0, 10, 10. And then, is there more than one choice possible in either A or B? The answer is yes. Okay? In part A, or part 1, I guess, any set of 4 repeats will have a standard deviation of 0. Because there is no spread. There's no distance from the mean. Part B, on the other hand, has only one answer, only 0, 0, 10, 10. Get us as far apart as we possibly can. Okay? Hoping this is making sense to you. Let me see if there's anything else that I feel like we really need to touch on. I think you could probably tackle letter N. It's creating a modified box plot. So you'll need to find your 5-number summary. You'll also need to check for outliers because it's a modified box plot. You'll draw your number line. You'll create your box plot. Okay. Letter O, very similar, is just having you check for outliers in each of these 4 data sets. So you'll do 4 sets of outlier calculations based on different quartile values, IQRs, all of that good stuff. I think you probably are capable of answering letter P. I'm going to go ahead and put the answers down real quick, just so that we make sure we're reading box plots the same. Letter R we will talk about next time we're together, as well as letter S, and that is the end of the outline. So let me go through letter P really quickly with you, okay? We're looking at 4 different regions: Northwest, Midwest, South, and West. I'll write those down. 1 is Northwest, 2 is Midwest, 3 is South, and 4 is West. Okay, and we're looking at the governor's salaries in 1993. So which group has the individual with the largest salary of anyone listed? The individual with the largest salary is going to be the highest maximum. To me, looks like the highest maximum value is from the South. Okay, which group? Oh, how much? Oh, man. Maybe somewhere around 125,000. Okay, which group has the largest median salary? Reminding you that this line in the middle of your box plot is the median. Also appears that the South has the largest median at about 90,000. Okay, which group has the smallest IQR? And what approximately is that value? IQR is range between the quartiles, okay? Range or distance from the ends of the box. I actually think that both of these boxes look pretty similar. I'm going to go with Northwest. It looks maybe slightly narrower. And that IQR, let's see, our Q3, let's say that's at about maybe 95,000. And our Q1, maybe somewhere around 75,000. So maybe it's about 20,000. Okay, which group has the lowest Q3? Q3 is the right edge of the box. The lowest Q3 is here in the West. And that is, let's see, at about 90,000. The top half of the Southern governors. Okay, so remember the median divides our data in half. So if we're looking top half of the Southern governors, that's going to be from median to max. That's top half. Make the same or more as what percent of the Western governors? Well, the median lines up here with the Q3 in the West. So Q3 to max is only one of the quarters, or 25% of the West. Okay, part 6 here says, what is the Spread of the lower 25%, lower 25% is going to be min to Q1 of the Midwest governors. So here's Midwest min, here's Midwest Q1. I would say that's about 65,000 to about 75,000. So that spread would be about 10,000. Okay, and then last question, number 7 says, which region has the widest middle 50% of their data? Middle 50% is from Q1 to Q3. So we're looking at the box here. Which one has the widest box, essentially? And the one with the widest box would be the Midwest. Okay. Hopefully you're getting the hang of reading Boxplots. One question that you might get asked is, which region has the most states or contains the most states? And I want you to remember that Boxplots are based on summaries. They're based on the 5-number summary. They're not based on raw data. You cannot see original values. We have no idea how many data points actually went into creating these various box plots. So if you're ever asked about specific amounts of data, you are not able to answer that with a box plot. You can answer percentages of data, but you can't answer specific amounts of data. Okay, I hope that makes sense. Let's go see if there's anything else to define. I think there's a few things that we've talked about that we could define. Oh, we can put the formula for variance on here. Variance isn't specifically on your formula chart, but that's because it's just standard deviation squared. So it's our standard deviation formula without the square root. So it is the sum of each x minus the mean squared divided by n minus 1. And the really important thing to remember about variance is that it gets no units. Okay. Measures of center, we can talk about measures of center, things that help us measure where the center of our data could fall. Sometimes we might use median as a measure of center. Other times we might use the mean. Very rarely we might use the mode. We could use the trimmed mean. Okay, anything that's giving you kind of an idea of where the middle of your data falls is going to be a measure of center. Measures of spread give us ideas about how spread out our numbers are. Okay, our most infamous one that we've known for forever and ever is range. We have also learned IQR, that's the spread for the middle 50%. And today we added standard deviation and variance to that list. Okay. Resistant to outliers means that it is not affected by outliers. We've already talked about the fact that the median is resistant to outliers. Okay, a couple other things that are resistant to outliers: quartiles, IQR, because it's only dealing with Q3 to Q1. What else is resistant to outliers? Typically mode is resistant to outliers. Okay. Non-resistant to outliers, things that are affected by outliers. We know that the mean is greatly affected by outliers, and the standard deviation is based on the mean, so standard deviation is also greatly affected by outliers. And of course, the range is affected by outliers. Okay. Hopefully that gets you in a good place for homework 3. I am really looking forward to seeing you guys on Wednesday. I hope you enjoy your super long weekend. Get some rest on Monday. I will be picking up homework 1, 2, and 3 from you on Wednesday, but I also want you to know that we're going to spend a pretty good amount of time answering homework questions if you have any, okay? I wouldn't say all class period, of course, but some pretty significant time doing that, okay? See y'all on Wednesday.